Hello and welcome to today's tutorial on another method for solving quadratics. This method is called completing the square. If you haven't seen our videos on factorization, click the link in the description for parts 1 and 2. Before we go on with this new method, we need to familiarize ourselves with some algebraic identities, namely the square of sums and the square of differences. Let's first take a look at the square of sums. X plus y brackets squared is the identity we will be calling the square of sums. If we viewed the term as bracket x plus y times bracket x plus y, we could expand the equation. Applying distribution, we find that bracket x plus y squared equals x squared plus xy plus xy plus y squared, which can be simplified into x squared plus 2xy plus y squared. Similarly, bracket x minus y squared equals x squared minus xy plus y squared, or x squared minus 2xy plus y squared. Now that we know what these identities are, we can begin to understand completing the square. The method of factorization is similar to what the name suggests. You are to manipulate a quadratic equation into a square identity to allow you to take the root of both sides. Let's demonstrate how that works. Take the equation x squared plus 6x plus 2 equals 0. If we want to change this equation to a square, we know that the intermediate term, 6x, must equal 2xy. This knowledge allows us to derive the equation 2xy equals 6x. Dividing both sides by 2x gives us y equals 3. This means that the identity x plus y bracket squared, the constant must be 9. This is because the last term of the equation is y squared. If y is 3 in this case, the constant must be 3 squared, or 9. However, in the example equation, x squared plus 6x plus 2 equals 0, it does not have 9 as its constant. We know that whatever we perform to one side of the equation, as long as we perform the same operation to the other side of the equation remains true. Thus, we can add 7 to both sides, which changes the equation to x squared plus 6x plus 9 equals 7. The left side can now be combined into brackets x plus 3 squared, showing the square of sums identity. Taking the root of both sides results in the equation x plus 3 equals plus minus root 7. The reason 7 is positive and negative is because when you square a negative number, the two negative numbers cancel out to create a positive number. This means that both positive root 7 and negative root 7 squared equals 7. From here, standard methods of solving equations take over. Subtracting 3 from both sides results in the equation x equals positive negative root 7 minus 3. This matches up to the maximum of 2 answers we should expect from a quadratic. Let's take another example. X squared plus 5x plus 3 equals 0. This is slightly different from the last example, as the intermediate term is now odd, but the same rules still apply. We derive the equation 2xy equals 5x. Dividing both sides by 2x results in the equation y equals 5 over 2. Y squared in this case would be 25 over 4. Our constant, 3, can be expressed as 12 over 4. Subtracting 12 over 4 from 25 over 4 gives us a difference of 13 over 4. We can add 13 over 4 to both sides of the equation to get the new equation x squared plus 5x plus 25 over 4 equals 13 over 4. This side can now be compacted to brackets x plus 5 over 2 squared. We take the root of both sides to be left with x plus 5 over 2 equals positive negative root 13 over 2. Subtracting 5 over 2 from both sides, and we have the equation equals plus minus root 13 over 2 minus 5 over 2, providing us again with the 2 answers to the equation. Let's walk through one last example. Take the equation 8x squared plus 16x plus 2 equals 0. The coefficient of the x squared is rather pesky, as it makes it difficult to compact the left side. However, we can solve this problem by dividing the equation by 2. Gives us the new equation of 4x squared plus 8x plus 1 equals 0. by adding 3 to both sides, the equation 4x squared plus 8x plus 4 equals 3, which allows us again to simplify, this time by dividing by 4. The final equation is x squared plus 2x plus 1 equals 3 over 4. The left side can be compacted into the equation brackets x plus 1 close bracket squared, which equals 3 over 4. Taking the square root of both sides results in the equation x plus 1 equals plus minus root 3 over 2. Subtracting 1 from both sides results in the equation x equals plus minus root 3 over 2 minus 1. That's it for now. Thank you for joining us for this tutorial on how to solve quadratic equations through a method called completing the square. Join us next week as we aim to prove the quadratic formula. If you enjoyed this video, please like and subscribe, and thank you for watching.